So the variation of electron affinity along a group, we have seen that. So electron affinity decreases along the group. அப்படின்னு ஏற்கனவே பார்த்திருக்கோம். அப்படின்னா என்ன அர்த்தம்? To take the case of fluorine halogen family, fluorine, chlorine, bromine, iodine, electron affinity is supposed to decrease from fluorine to chlorine. But in actual case, electron affinity of fluorine is less than that of chlorine. So chlorine on the group la adutha element ah dhaan varudhu. As per the group trend, it has to decrease. It has to decrease na enna artham? Electron affinity of chlorine should be less than electron affinity of fluorine. But in actual case, this is the truth. That is, electron affinity of fluorine is less than that of chlorine. இதுக்கு பேரு அனாமலின்னு பேரு. இந்த மாதிரி அனாமலி இருந்ததுன்னா ரீசன் கேட்பாங்க. So general expected trend along a group is decrease. But for these two elements, that group is not the trend is not decrease. That is, electron affinity of fluorine is less than that of chlorine. Why? It has to be explained in terms of electron repulsion. So இதுக்கு வந்து hint ஒரே main answer வந்து electron repulsion தான் reason. We will illustrate example வச்சு சொல்லுவோம். So you have seen that electron affinity is the energy released when one electron is added to the neutral atom, causing the formation of negative ion. அப்படின்னு நம்ம பார்த்திருக்கோம். So to fluorine one electron is added to form fluoride anion. Chlorine one electron to chlorine one electron is added to chlorine atom, forming chloride anion. So some energy is released in both cases. That is called electron affinity. It is called electron affinity. But the electron affinity of fluorine is less than that of chlorine, which is against the general trend. It has to be explained because fluorine, if you compare, fluorine has smaller size than chlorine because along the group size of the atom increases. Along the group size of the atom increases. So the size of fluorine, that is radius of fluorine, is less than that of chlorine. For smaller size, the extra added electron goes to the same shell, causing a electron repulsion. So smaller size now, this is explained based on the smaller size. So along the group size increases, but for this fluorine is the first element, it has the smallest size. We are comparing for fluorine and chlorine. So fluorine has smaller size than that of chlorine. So in both cases one electron is added, they are forming only univalent anion, both are halogens. In spite of this, electron affinity is less for fluorine because the extra added electron causes an repulsive force or experiences a repulsive force with the electron already present in the particular shell. So that is called electron repulsion. So extra added electron generally should go for pairing. Pairing மாதிரி போயிடுச்சுன்னா electron affinity will be realized. But here the extra added electron causes some electron repulsion because both the electrons are negatively charged. They have like charges. So like charges repel each other. So there is a competition between pairing and repulsion. There is a competition between pairing and repulsion. Pairing means they tend to spin in the opposite direction. They tend to settle. Repulsive means one electron is pushed out of the other. Here repulsive force is predominant than the pairing. So pairing is not taking place quickly. Repulsive force is predominantly taking place. So because we have to extra work against this repulsive force to add the electron. That is why electron affinity of fluorine is less than that of chlorine. That is to be noted. So once again to repeat, along the group electron affinity decreases. As per this trend, electron affinity of fluorine should be higher than that of chlorine, but in actual practice it is less because of the electron repulsive force. So the extra added electron, some energy has to be spent for the extra added electron against this repulsive force, so which causes the abnormal change in the electron affinity to be noted. So this is to be explained based on the electron repulsive force, which is competitive or predominant over the pairing of the electrons. So நம்ம வந்து ரெண்டு ஸ்கேல் ஆஃப் எலக்ட்ரோநெகட்டிவிட்டி பார்த்தோம், Pauling scale and Mulliken scale. So now we will see some numerical sums on these Pauling and Mulliken scales of electronegativity. So question என்ன கொடுத்திருக்குன்னா, calculate the electronegativity of chloride ion from the data below. என்னென்ன data கொடுத்திருக்குன்னா, bond energy of hydrogen molecule, bond energy of chlorine molecule and bond energy of HCl molecule. மூணும் கொடுத்திருக்கு. So bond energy of hydrogen molecule is given as 104 kilocalories per mole. So bond energy energy required to break the covalent bond between the two atoms. So bond energy of chlorine atom is given as 36 units, that is kilocalories per mole. Bond energy of hydrogen chloride is 134 kilocalories per mole. We have to find. So as per the Pauling's equation, geometric mean difference ni ஏற்கனவே பார்த்திருக்கோம். Delta is defined as the difference between the bond energies of heteronuclear molecule and the geometric mean of bond energies of homonuclear molecule அப்படின்னு பார்த்திருக்கோம். இந்த இடத்துக்கு homonuclear molecules are hydrogen and chlorine. Heteronuclear molecule is hydrogen chloride. So delta equal to, for this Pauling's equation for this system can be written as delta equal to EHCl minus EH2 into ECl2. So EH2 and ECl2, the geometric mean is taken, product, and then taking square root gives the geometric mean. So I have to substitute. HCl is 134 kilocalories minus hydrogen 104 and 36 kilocalories. So it will give rise to 72.82 kilocalories. So this is the delta value. So electronegativity is given as 0.208 root delta equal to the difference in electronegativity between the two atoms. That is, if you consider these two atoms, hydrogen and chlorine, so the difference in electronegativity between hydrogen and chlorine, here chlorine is more electronegative. So if you take this value you will get minus. Chlorine is more electronegative than hydrogen. So to get the positive value you will get this value. So 0.208 into delta we have seen 72.82, that is the electronegativity. Electronegativity is the power of attraction of central electron pair towards the particular atom. Here we are considering two atoms, hydrogen and chlorine. So power of attraction is more for chlorine, less for hydrogen. So the differential power of attraction is reported as electronegativity. So you will get 1.77. So this is the Pauling's scale of electronegativity for hydrogen chloride. That is, chlorine is 1.7. The numerical value suggests that the numerical value is non-zero. HCl minus XH is non-zero. Or in other words, HCl is greater than XH. Or in other words, chlorine is more electronegative than hydrogen. So this gives the Pauling scale. Next scale of electronegativity is Mulliken scale. Mulliken scale of electronegativity. So Pauling scale, Mulliken scale difference. Mulliken scale is almost 2.8 times as that of Pauling scale.